So welcome to this week's episode of Leaders on a Mission, where I'm joined by inspiring leaders driven by the impact of creating a healthy and sustainable world. In today's episode, I'm joined by Tom Adams, biotech entrepreneur and CEO of Pairwise Plants, a company using modern advances in science and technology to change the whole dynamics and category of the fruits and vegetables we eat. Look, Tom, it's great to have you on the show today. Thanks very much for joining us.
Thanks for having me, Simon. It's great to see you again.
Absolutely, absolutely. So maybe we'll start, Tom. Let's take it all the way back, really. I'd love to hear about some of the kind of key influences on you as you were kind of growing up as a young Tom.
Yeah, that's always a really complicated question to think. What are the real key influences? And I grew up in I think everyone probably thinks of the way they grow up as a fairly typical family. I actually was a pretty large family, and I grew up in the 60s and 70s. My family, there were 6 kids in the family, so it's a big family. And I'm the 5th of 6, which I think is a great place to be, because you have older brothers and sisters that have broken all the rules, and your parents are fairly numb to anything you're doing by that point. So you get a lot of freedom. At least that's how it felt to me. I think, my overall, the 60s and 70s were, an interesting time. And I think in my family, there was a lot of emphasis on, my father both my parents were quite educated. My father's a professor in agriculture and in dairy science. So I had a lot of exposure to agriculture. And, there wasn't really pressure to perform in school, but there was sort of an expectation hidden behind everything that people would learn and do something useful with your life, and do something that would make a difference. I think from my ag perspective, I think I started gardening probably when I was 2 or 3. I have memories of like taking bottles of water out to water the corn plants in our little back garden. I think I was actually running our family garden by the time I was 10 or so. So I always had an interest in plants and science and technology. In high school, I remember I read some papers on the early plant transformation studies of Mircea and Skoog, and how you could take plant cells and regenerate whole cells. It just seemed like a fascinating component of biology. I got pretty interested in plant science from that point on, and ended up going to college to study plant science and graduate school. So really, lots and lots of different influences, but I think those are some of the key ones.
Yeah, absolutely. But you followed, it's interesting, from such a young age, you kind of followed that kind of route and that path throughout your whole career, essentially.
Yeah, at least looking back, you can drive that kind of, so, but I think, we all have interesting childhoods, I'm sure.
Yeah, but tell me, with your father, was he a pure academic, or had he ever worked in the?
Yeah, it's actually, he had a little bit of an opposite to my career, because when he worked for a company called Eastern States, where he worked on basically animal nutrition questions, is mostly with milk dairy cattle, and then his company got acquired by somebody, and he decided he didn't want to hang around, so he ended up becoming a faculty member. So we moved around a couple of times for universities, but yeah, he's an academic. His later part of his career, he was an extension academic, so he very applied science.
No, great. And just interestingly, you said you're one of 6. How many of the 6 ended up in agriculture or scientific kind of fields around agriculture?
I think it's kind of an influence of sort of how I was describing my childhood. I think we didn't really get pushed in any direction. So I'd say all of my siblings actually have a fairly diverse, like 2 of us have PhDs, my brother as a mathematician. So sort of a science path, but not an agriculture path. I'm actually the only one with really truly involved in agriculture.
Yeah, no, great. No, thank you for that. And tell me, so when you were completing your doctorate, what were were you always aligned to wanting to go out into the business world with your skills, or maybe tell me a little bit about your aspirations when you were starting out, as it were?
Yeah, I mean, again, you go back to the 80s. If you were going for a PhD, your goal was to be a faculty member. Your goal was not to go to industry, and I was very much down a very pure science path, and I actually did go from from getting my PhD, doing a postdoc, and I had a faculty position at Texas A&M for several years. So that was what defined success back then. There were not the startup world was a lot different. There were different waves of plant biotech startups. I think there was a wave around that time that were the first wave that sort of followed the ability to transform plants, and companies like Calgene and Agricedis and DNAP got formed, and they had an important role. But there are very few people going for PhDs in plant science that was their goal. It was actually more often later career moves that would go into industry.
Okay. So how did you find yourself? I mean, you had a career, essentially it was 20 years at Monsanto. So what kind of got you into the organization
Yeah, it was kind of my move to Monsanto was, I like to call it my 20-year sabbatical. So, I mentioned I was a faculty member, and I had this opportunity. So as life went on, you're an academic, you're publishing papers and doing science, and you are looking for ways that what you're doing could be applied, and you're talking with companies and looking for those as ways also to fund your research. And I got this opportunity it's the early days of genomics, or the Human Genome Project and so on. And because of some previous contacts, I managed to get this opportunity to go to Millennium Pharmaceuticals, which was really the leading sort of pharma genomics company in the late 90s. They ended up being acquired a few years later by Takeda for, I think, about $12 billion or something. But so I did a sabbatical, or a leave of absence, to go to Millennium, where it was this great opportunity. They treated me like an employee, even gave me stock options for my sabbatical. And I got to see the inner workings of this company, and I was doing it kind of as a tryout. And while I was there, Millennium decided that all this effort going for the pharmaceutical space had an opportunity to be played in agriculture. So they formed this little effort called Millennium Ag. And because I had this background in plants, et cetera, I got sucked into that path. And actually, about a week before they did a big deal with Monsanto to create a new company called Syria Genomics, they realized there was going to be Monsanto realized they were making this big investment, but there wasn't really a research plan for the company. There was a vision for it, but not a research plan. And so they called me up and said, could you put this together? You got a week. And I spent the next week with leadership at Monsanto and leadership in Millennium, and we put together a plan. And I ended up basically starting up this company with a few other people. And so it was really, really a fun time, but it was a subsidiary of Monsanto. And therefore, I then spent the next 20 years on that sabbatical with Monsanto.
Yeah, absolutely. And tell me, 20 years, I mean, no doubt you had some great times. Maybe as you reflect on your career there, maybe give me a sense of, say, a reflection or two of either a project or a role that you did that you look back really fondly on.
Yeah, I mean, Monsanto was a really interesting culture to be part of, especially on the technology side, because we really, this was an exciting time from, the late 90s, of this ability to really change some cropping systems, and being able to help growers with some of the challenges they had around, especially pests. And, it was a wonderful opportunity to do that. And I got to be involved in that. The effort to try to then move into the next sort of changes in plants and what we do is, one of the board members at Monsanto always described it as megapreneurial, because it's a big company, but it had this entrepreneurial thing. So I was able to really start up many different efforts in Monsanto. I was involved in early days of some of the attempts for using transformation to change other aspects of the cropping systems. But I also got involved in coordinating really big push on what's become a pretty large space of this, what we call bioag, so microbials as supplements to crops. I was involved in setting up a big program on that. It was really exciting. We did a relationship with Novozymes and didn't do it on a small scale. We did it on a big scale. And then, actually one of the more exciting points was also when gene editing became something that could really work, which has ended up in leading to Pairwise.
Yeah, no, great. Absolutely. And at the time, you were quite involved with some of the RNA technologies at the time, right?
That's right. Yeah, so I had it was kind of because I am a biologist, but I think it was about 2008, I was asked if I would lead our chemistry group. And so you put a biologist in charge of a chemistry group, and Monsanto wasn't really a big producer of new chemistry. It was more about how you use chemistry in cropping systems to control things. And one of the scientists was exploring challenges on how weeds were becoming resistant to Roundup, and the way they were becoming resistant was by expressing the genes at a really high level. And he had this idea that maybe you could use RNA, double-stranded RNA as a RNAi approach to turn that gene down and make them sensitive to glyphosate again. And he started messing around in greenhouses, and he started killing the weeds by spraying on RNA with the glyphosate, and was showing that it was knocking down the expression of the gene. So we then took that technology and tried to amplify it. And there's certain bugs that you could use it to control, and you could control weeds under some circumstances. So there's been difficulty scaling the technology to where it could really be used in the big acre crops, but it was very exciting time to be part of this sort of novel discovery. Still waiting for it to become a big commercial success, but pretty exciting.
Yeah, no, absolutely. Well, obviously with the RNA, we see it a lot more in relation to the kind of issues we've had with COVID and some of the kind of vaccination.
No, for sure. The Moderna comes out of that big pharma push that was happening at the same time about how to use RNAs as treatments. And they've been working on that for many years, and were positioned in a great position to make a big difference when COVID came along.
Yeah, no, absolutely. So tell me, so with Pairwise, had you always had that kind of, because clearly you were operating in that environment in Monsanto as a mega, what was the word you used? A mega?
Megapreneurial.
I love that. Yeah, I've heard of the entrepreneurial, but I love that. And was it always a dream and a passion or an idea that you were going to lead your own company?
Yeah, I would say probably, yeah. I mean, it was a great opportunity I had in Monsanto, in that I got to work with almost every company that started up in the agricultural biotech space in the last 20 years. I had opportunities to be interacting with them, and I was always a little bit envious of the fun and the focus that they had in that small team environment, and the ability to really center on one problem and try to solve that problem. So I always gravitated to that. And I mean, as a leader, I tend to try to fill the gaps that the rest of my team might not be doing. So, if you've got a really great senior leadership team doing all these activities in a big organization, then it gives you time to look outside. So I would tend to spend a lot of time looking at outside opportunities to really accelerate new stuff, and really enjoyed that space. And one of the frustrations I always had in Monsanto was all this technology, but because the core business was really grains, crops that are on hundreds of millions of acres, we had this technology, but we didn't really apply it to some of the crops that people interact with. And that's when gene editing was in its early stages, and you could see how it could be applied into the big row crops, but really excited about the idea that it could be used to impact things in a more direct way for people. And it's hard to recognize the impact of more productive corn, field corn that's being fed to cows and pigs and chickens and cars, not that much of it going to people, as opposed to really changing some of the things that we eat every day.
Yeah, no, absolutely. So so when you set Pairwise up, what were the kind of problems and the challenges, I suppose, that you were looking to solve when you kind of co-founded the business?
Yeah, again, when we started into this idea that the technology ought to matter beyond row crops, and with my team partner Haven Baker, my co-founder, we started thinking about what's the really big opportunity and problem. And we like vegetables and fruit and vegetables, but the more we really thought about it, we realized we like them, but nobody eats the amount that they should. we're, I think, 9% of people in the United States, 9% of adults eat the recommended amounts of fruits and vegetables, and started trying to think about what could we do to change that. And it's not an easy question. So we've hit on some hypotheses based on looking at things that have helped to move the needle on particular products, and that's so we really want there's eating enough fruits and vegetables is a huge component of health. And you go for a snack and you can choose easy peel mandarin, which has been a real success in driving consumption of fruits because they're easy portable fruits, or you choose a bag of potato chips. It's a lot healthier for you if you pick the easy peel mandarin. That's become our mission as a company to really take down some of the barriers that keep us from eating fruits and vegetables.
Got it. Okay. And I was wondering, 9%, that's so low. What are the fundamental, what are the top 2 or 3 kind of reasons why it's so low, do you think?
Yeah, I mean, I think you could probably point out a bunch of things, but part of what we've hit on is, I guess, two or three components. One is convenience, that most fruits and vegetables are really not that convenient. So if you are competing with a snack, most things have to be cooked, prepared. There aren't that many things that you can just take, like the easy peel mandarins, the cuties and halos, and just go somewhere with. They're a job. So it's not as easy to fit into your lifestyle. Another challenge that I think there's examples where it started to be overcome is just availability, that they aren't, all of them aren't, the seasonality makes it so they don't necessarily become part of people's routine. And, there are examples, for instance, blueberries in early 2000s, after about 60 years of breeding, we got blueberry varieties that could be grown all over the world. And they started becoming available all year rather than just a summer fruit. And there's been a 4x increase in consumption of blueberries by making them easily part of people's lives. So I think those are a couple of the different components. And then it's just, you're competing with all this change that's going on in the processed food space, and all the different varieties and things that you can change. And only 3% of the innovation in the grocery store occurs in produce. It's a really small amount. So I think part of it is just creating the interest and the excitement. There's been marketing campaigns to try to get people to eat more fruits and vegetables, and the interesting result is it doesn't get anybody to eat more fruits and vegetables, but it makes more people aware that they should eat fruits and vegetables. Right. So yeah. I think that it's not a lack of knowledge that we should eat them. It's just not easy to fit into our lifestyles.
Yeah, no, great. I did say, someone did tell me on a recent report, a World Health type of report, that the issues and challenges with people not eating the right things was more prevalent than the people that were, eating the fats and the sugars and the bad things, for instance. And I was really surprised to hear that. Is that something that you've heard as well, or is that?
I guess I'm not quite sure I understand the comment, but I think there's an interrelationship there, right? Is that the lack of eating healthy foods is not good for us, and the eating foods that are less healthy or predominating our diets with less healthy foods isn't good for us either. So absolutely.
Well, we'll leave that question there, definitely. But yeah, no, it was an interesting. Report I read, actually. So tell me then, yeah, when you think about this and you think about what you want to kind of create, is it a whole new category of products? And maybe talk me through a little bit around that kind of vision for when I'm going into the grocery store in a few years' time. What am I going to see there?
Yeah, if I maybe can start with a sort of longer term vision, and then step back to some of the things that we're doing shorter term, and we do expect to have products reasonably soon. But really, if you think about again, this idea of competing with snacks and really making it easier to choose a fruit than a bag of potato chips, one of our longer term projects is to create a cherry that has no pit. and to change some of the growth habits of the cherry tree so it's easier to produce cherries year round. Today, they're predominantly still a summer fruit, but we think we could make them more easily grown year round and not lack a pit. Now you can eat cherries like grapes. You can just pop them and eat them. You don't have to deal with pits and cutting them out if you're feeding your kids and all that. So it becomes a much more snackable food. But now expand that idea into all the stone fruit. And maybe rather than just getting rid of the pits with some of the bigger stone fruit, we make them maybe a little bigger than the cherry, but make them more mouth size. So you can actually turn them into an easy snack to be eating while you're on your Zoom call. Instead of Cheetos, you can be eating some little baby peaches. So I think that's kind of a long-term vision, to really create these kind of things that fit into people's lives. Shorter term, the first set of changes that we're looking at is in the leafy greens. And we kind of came to this one a little late, but I've gotten kind of excited about it because it didn't immediately jump out at me as something that would be that different to a consumer until we really started to think about the salad category. And it turns, there's a lot of kind of, looks like a lot of choices in the salad category when you go into the grocery store, but it's a lot of sameness, really. It's just different labels on essentially the same leafy greens. And if you look in that leafy green space, the predominant leafy greens consumed are iceberg and romaine, which are relatively low in nutritional value. You get some roughage, but you don't really get a lot of nutrition out of those. 2/3 at least of the leafy greens consumed are those. There's a third that fit into what would be called a healthy category, but even in that healthy category, almost all of the leafy greens consumed are really the spinach, which is not really, it's not like kale. So it doesn't have the real nutritional benefits of kale. It's got, I think because of Popeye, I guess we've got this idea of spinach as being real healthy, but it's not real. Yeah. It's not nearly as nutritious as kale or arugula. So one of our scientists had this idea that, we care about health, we care about healthy eating. There are relatives of kale that look just like lettuce, a lot more like romaine, and have that kind of leaf quality of a romaine. The problem with them is that they have a pungency flavor. So when you eat them, they taste like horseradish. So typically if they are eaten, they're eaten cooked, because that eliminates that horseradish flavor. So we had this idea of, well, how complicated is making that horseradish flavor? And it turns out it's actually a pretty simple bit of biochemistry that goes on in the leaf to create that flavor. So we had the idea we could use these tools of gene editing to eliminate that pathway, which we've done. And now we've created a whole new category of leafy greens to allow bored salad lovers to have an opportunity to eat on the nutritious side, but have the benefits of eating what they tend to go to anyway, which is the romaines and icebergs.
Fantastic. So there's a combination there of what you've outlined of convenience, for instance, and also the health kind of the health qualities as well, as you've just outlined there, which so there's a combination of both of those kind of forces that are helping drive some of the kind of product development kind of stories.
Exactly. And ultimately our goal is to really help everybody in the channel. So in the next product in between the stone fruit is that we're working on is a blackberry, and there's some, and then other caneberries, but there's some opportunities in the berries to do sort of this, but also help everybody from the grower to the consumer with better products. So it turns, we've asked consumers about properties of blackberries. A lot of people don't like the seeds in blackberries, and we think we have the technology to eliminate seeds in blackberries, just like we've eliminated seeds in grapes and watermelons and many other things. So we have the ability to make a seedless blackberry. Then at the same time, to create a blackberry that has a more consistent, better flavor and lacks thorns, so it's easier for growers to pick it, and also is more productive by changing a couple of properties so that the grower can produce more, the consumer can get something that appeals to them and beyond the ones today, and hopefully we'll eat more. And in that category, after blackberries, there's a natural blackberry in North America called the black raspberry. It turns out it's basically a wild raspberry, but it's black raspberry. The red ones come from Turkey. The black ones come from are native to North America. but they're pretty wild. So we're domesticating them, and they have a relatively large seed. We're getting rid of the seed. They have a really rich, deep flavor. They're really good, but they also have a anthocyanin content that's much higher than even a blueberry, or they're sort of similar to like the acai berry. So quite a rich, healthy berry. So we want to introduce essentially a fifth berry into the category that has these additional health properties and flavors from what we're used to.
Wow, that sounds really exciting. And how long would it take then to, when you think about some of the product categories and your vision to actually, really experience, as a consumer, experience a different kind of setup when I go to the grocery store?
Yeah, I mean, our expectation is that you'll probably be a little limited in availability in 2022, but by the end of 2022, we'll have some of the new leafy green varieties and salads in grocery stores in North America, beginning in North America. I see great signs that the UK is preparing to separate their view on gene editing from where Europe is. So maybe quickly we could follow in the UK. So maybe you'll get one soon too.
Absolutely. Thank goodness for that, and thank goodness for that as well. It's we've been a little bit paralyzed by the by the European kind of view on things, as it were. And absolutely, UK could be a good market.
And then the berries are a couple of years behind that, and it's probably, I would guess, a decade or so before we can really get the stone fruit, because the trees take a longer time to develop. We're trying to change that so we could create a faster turnaround innovation cycle on the trees as well, but you have to go through the first innovation cycle.
Right. Okay. That's slightly the longer term kind of innovation funnel, was it?
Exactly.
Really. So we're talking about. So at the moment, how long does it take, for instance, to get a cherry tree to kind of grow and to blossom? Good fruit.
Yeah, well, maybe a couple of things about cherries. The innovation in cherries, the Bing cherry, that was actually bred in 1880. So the Bing cherry every Bing cherry tree is a clone of that original Bing cherry tree that was identified in 1880. So that's sort of the innovation pace isn't real high. There's been a few varieties that are sort of Bing-like that have come out, but it takes about 25 years to launch a new variety. If you're starting an orchard, I think it's a few years from, it's a couple of years to get a plant that you can put into the orchard, and then it's a few years from when you plant it to start getting cherries. So if we go through our process of having to create the edited versions that we want and then get them in, it's, before you're selling cherries, it takes 10 years or so.
No, great. Now tell me a little bit about the technology, because, talking about the kind of gene editing and, as someone so interested in work with technology, how different and how much opportunity does something like gene editing really enable you right now compared to what you were using before, for instance?
Yeah, so gene editing it's a pretty remarkable, the way in which we're using this tool in big organisms like plants and humans is a pretty remarkable discovery that really is, I guess it's less than 10 years old, that the group at Berkeley figured out how to use this bacterial viral protection system to direct things to specific places in a genome to cause some base changes. So could go on about how bacteria use it, but just to get to the actual technology. Now, some organisms we've been able to edit genes in really for quite a long time, and something like a yeast, we've been able to do really specific modifications. But when we get to organisms with more large, complex genomes, like a corn plant or a cherry tree, it turns out to be really, really hard to do precise changes to a gene. And that's why the path that people have taken with what we call GMOs has been just inserting new copies of genes or genes from other organisms fairly randomly in the genome. And that's a pretty imprecise process, really, at the end of the day. So you have to do a lot of them and then sort of sort through what you've done and figure out which ones have done good things and which ones haven't. With gene editing, you're able to really precisely target a specific gene and make a very specific change in that gene. So if, for instance, I know that in this particular, I'll go back to the cherry tree variety. It turns out that there's actually a mutation that's been identified in plums that results in pitlessness. So there's a pitless plum. It's not a commercial plum because it's in a bad variety of plum. Hasn't ever been commercialized. And you can cross plums and cherries. So you could by breeding, you could create a pitless cherry. It would take you about 150 years, we sort of estimate, because you have to, once you cross them, you get new trees, but they aren't plums or cherries. They make some kind of fruit. And you'd have to just keep crossing it back to the cherry until they're cherries again. Gene editing, I know what that mutation is in the plum. I know exactly what it is. So there's an A that changed to a C. So I can now go into the cherry tree and change that A to a C because it's got that gene. I just need to make that change. And that's the only change I made. And now everything else is cherry. And in fact, that's even cherry. It's just made that one change in the gene that makes it so the pit doesn't develop.
Amazing. Yeah, absolutely amazing. So you're not inserting anything. It's just literally a very, very specific, taking away a very specific gene.
Yeah, you could use these tools to insert things. And I think as the technology continues to develop them, there's more broad acceptance of how we can change things. Some of the GMO will also be benefiting from use of some of the same tools. But the way we typically talk about gene editing is really using just the diversity that's already available in the organism. And it's just making precise breeding so that, normally if I take a cross between two parents, your kids have lots of properties of you and your spouse, and you have 30,000 genes that are sorting around, and the odds of getting the right combination when you pull the slot machine of exactly what you wanted are really low. So it's this big numbers game. And with gene editing, I can reduce that numbers game to just create the thing that's exactly like the one parent, except for the one change that you'd like to be coming from the other parent.
Yeah, no, that's great. Tell me, in your lifetime of science, how significant is this discovery and this work with it compared to all the other things you've seen?
Yeah, it's one of the great things about science. It's in the moment, it feels like, I missed it. It was so exciting back then. I remember when I started graduate school and it was right after that first evolution of cloning, and right in the 70s when Genentech and some of these companies were forming. And I benefited from that because we had all the tools that they developed that allowed us to study genetics in a different way than we had before. But I always felt kind of bad because I was like, boy, it would have been so exciting to be the one who figured that out and so on. And then you move on, and then suddenly there's a discovery like in the 90s of RNAi, that all organisms are using these what we thought were just messenger RNAs. There are these other RNAs that have this incredible role in controlling the expression of different things and have huge determination. And it's a tool that you can use to think wow, that was a cool thing. And then plant transformation. Oh boy, I wish I could have been there. So I think gene editing sort of falls into that same category. And probably people, someone coming into science today is thinking, boy, it would have been fun to be part of figuring out how gene editing works. But 10 years from now, there's going to be, the way it will have advanced, it'll be, looking forward, it'll be 10 more things that are just as big. So it's science is exciting. It's fun. You're always discovering new things.
Absolutely. It really is. It really is. And tell me so the challenges with the gene editing then, I know in Europe, we're not necessarily able to apply it because of the strict rules around it's deemed as being kind of GMO, right? From a European perspective. Is that right?
Yeah, I mean, Europe has an interesting approach, and of course the EU is really complicated, but they basically, everything, if man is involved in it, including traditional breeding, is considered GMO. So, which is fine, it's genetically modified. And then they took, when they came out with the original law, they said, well, we'll say everything's GMO, but this set of things we're going to pass, and they don't have to go through these special tests because we've been doing them for a long time. So then traditional breeding fell into that category. So when they were faced with gene editing, I think there was a debate of, is this traditional breeding or is it not? And they came down on the side of, since it isn't really what we were doing before, even though it's the same outcome, we'll treat it more carefully. So they fall into this category that requires a lot of extra pre-market regulatory studies that is unique right now to Europe.
Yeah. Okay. All right. But in the US, you don't require that.
Yeah, it's a continuing to evolve path, and the predominant thing that's required in the United States is that you demonstrate that there are no transgenes, no genes from other organisms, that all you've done is modify a gene. And then there's some categorization around basically demonstrating that this is something that could have occurred in nature. So if it's something that could have occurred in nature, then it doesn't have any extra level of pre-market regulation. I mean, of course, all food is regulated, and there are regulations around everything, but not the very burdensome regulations that have occurred with GMO.
Yeah. Okay. No, thank you for that. You just got a very nice way of explaining these technical concepts in a very kind of layman terms, actually.
I appreciate that. Thank you. Appreciate the feedback.
Thank you for that. And tell me, so I'm fascinated in your kind of route to market, or the route through the channel, actually, when you think about, are your customers essentially the grocery stores? Are they the growers? How do you see yourself building the collaborations with across the value chain?
Yeah, I mean, it's still evolving since we haven't come to market yet. But our view is, and in these, one of the challenges in these smaller crops is you really do have to participate in the whole value chain in order to really pay for the research that's being done. So in order to do that, our goal is to change a little bit the marketing process in produce as well. And typically marketing in produce is non-existent. It's the compared to the CPG space where people might spend 10 or 15% of revenue on selling their unhealthy Oreos or whatever. We're in produce, it's like 0.5% of revenue that goes to marketing, nothing to people. So our idea is that we really want to differentiate with genetics, and then we want to use marketing as a way to really help people understand the differentiation and drive it. So our goal is to be really good at both of those, and then be extremely good at partnering through the channel. So working with the traditional packer shippers and growers to produce a single pathway through the channel that we can market these novel salads and novel berries and stone fruit.
Yeah. I've seen, actually, I think it was in Whole Foods, I've certainly seen categories now of leafy greens, for instance, where they're being branded maybe a little bit different to how they were a few years ago. Actually.
Yeah, and I think some of the indoor producers, some of the vertical farms are producing some branding around that. And I mentioned the easy peel mandarins. I think that's probably the best example where the halos from the Wonderful Company, at least here in North America, have really gone to a more traditional marketing approach, and it's really driven the category and driven. Citrus was actually a shrinking category until the easy peel mandarins came along, and now it's a growing category, and that's the #1 snack fruit and snack fruit in America.
Great. So it's really about changing the narrative and changing the story around.
Exactly.
It. Yeah.
Exactly.
And I figure that the kind of company that you're building as well would probably have to be so multidisciplinary as well, in terms of how you're building it. But you've got the biology, you've got plant breeding. Tell me a little bit about, I suppose, the dimensions that you need to bring into the company to grow, as it were.
Yeah, I mean, it's one of the really fun things and one of the really challenging things. And part of what you described there is actually probably the easy part is just building, because those are both within a technical sphere. So yes, you have to build out, but they're all part of the technical side. But as I said, we want to be leaders in genetics and leaders in marketing. So we also are bringing on people who really their expertise is more around understanding customer segmentation and understanding what people, how to help people see the benefits of the products that we made. And yet our roots are as a technology company. So, I think what the commonality is the passion for the mission the company has. So we all come together on this idea and the belief that really, people should eat healthier fruits and vegetables, but it's not their fault they don't. It's our fault for not providing them with enough choices and enough things that fit into their lifestyles. And it's a mission that people can get behind. And then it's huge fun learning from people who have spent their lives doing something totally different than you, like figuring out how to market products and I always I always think that the most interesting things happen at the interfaces. It's just like chemical reactions. They happen at the interface between two solutions. And that's what happens when you start bringing people together from different disciplines.
Yeah, that sounds great. It really does. And you find that people are joining, because you're about 100 people, right? Am I right in thinking?
Yeah, we're about 100. We'll grow probably about 30% this year. We've got some significant growth we're doing to start building out the commercial pieces.
Absolutely. And are you finding that people are melded? The modern day employee these days, is it really about the connection with the mission, the connection with the impact, and doing something different in your view?
Yeah, I mean, of course, like all companies, I think we've had a little bit of challenge with the current period where we've got many people working from home. So it changes that dynamic, but we've done a lot of things to try to keep it going. And I'm really glad or happy, fortunate that we'd had the company going for a couple of years, and most of our employees already existed before things started shutting down. So we'd already created good friendships and good connections, and we try to work to maintain those. But yeah, it's a challenge with the work from home to keep that going. But we've got a very connected group, and as I said, I think everyone, without a doubt, connects to the mission, and I think that's one of the big values of having a mission. And it's easy to communicate. It's easy. Everybody that we hire has in common that they are a consumer themselves, and they eat fruits and vegetables, and they have their own opinions. And we have a lot of fun trying to, brainstorm around, what is it that would make a consumer eat more of this?
Because they are all consumers, so they've all got opinions, basically.
Exactly.
It sounds like you have a good time. It sounds like I wouldn't say, I'm not going to use the word fun, but it sounds like it's very excited, highly impactful, and clearly you're doing something you really love doing. So no,
it's been very fun, and I think if you ask most of our employees, they're having fun. We would all love to be able to get together again in larger groups.
Yeah, no, I'm sure you will, hopefully at some stage this year. But Tom, it's been an absolute delight to have you on the show. Thanks very much for coming on, and wish you guys all the very best for the future.
Thanks, Simon. I really enjoyed it. It was fun.
Excellent.